Hello everyone, in this video we're going to be looking at how you can calculate the percentage by mass of an element in a compound. And this is particularly aimed at those studying Key Stage 4 chemistry, so GCSE level chemistry. You wouldn't really touch upon this topic in Key Stage 3. So let's just pick a very random compound to begin with, and I'm going to go for KCl. That's potassium chloride. Compound is essentially a chemical made up of atoms from more than one element. So we'll just make a note there so we're clear. So the K is the chemical symbol for potassium. Cl on its own is the chemical symbol for chlorine. But together KCl is what we called potassium chloride. So the fact it ends in IDE, I'd suggest that this is a salt that we've made. So we've got potassium chloride there. And now let's say that we want to find out the percentage by mass of just the potassium. So just the potassium in that compound of potassium chloride. Now, we know that each element has what's called the mass number. The mass number tells you the number of protons and neutrons that you find in an atom of that element. So if, for example, if we just draw a quick sketch, if you look at the periodic table, you might see something that looks a bit like this on one of the bits. So just very roughly, we'd have, let's take K there, it would say the name potassium. And then you might find a variety of numbers on it. And the mass number is usually the bigger number on the top. And for potassium, it should have number 39 at the top. Now that 39 there, that's the mass number. Now we give that symbol, or we give that number rather, the symbol A with a little r. Now that means relative atomic mass. We use the term relative because certain elements have, or certain atoms have isotopes. And isotopes are when we have atoms that perhaps have a different number of neutrons within their atoms. So you can have an element like potassium and it may have different isotopes whereby the different atoms have different number of neutrons. So the mass number may change. So we've got the mass number, but we usually refer to it as the relative atomic mass just to take into consideration those isotopes. We can see potassium has this mass number of, or AR number, let's say, of 39. Now the relative formula mass of a whole compound is found by adding, if you think about it, like adding all the mass numbers up together. So we know that the mass number, or the AR, the relative atomic mass, let's say, is 39 for potassium. So K has an AR value of 39. We need to work out the AR value for chlorine on its own. And that, when you look at the periodic table, has a value of 35.5. So the relative formula mass we find just by adding them all up together, and that comes to a total of 74.5. And we give that a symbol of MR. So AR is the relative atomic mass, which is just the mass number of essentially one element, and the MR is the relative formula mass, the mass of like the whole compound and every element of that compound added up together. So you could think of it a bit like this. If K on its own has a mass number of 39 in AR, and the MR of the whole of potassium chloride is 74.5, we want to know how much potassium we have as a percentage of the whole thing. So we almost treat it like a test score. We have 39 for the potassium. We want that out of the 74.5, and we want that as a percentage. So we can do that sometimes 100. And that is how you actually work this out. So you would do 39 divided by 74.5 times 100. Because then what you're looking at is how much potassium you have as a proportion of the whole thing. And if you do that sum, it should come out at around 52%. And that is simply it. If we just do one other example just to show. So you may get a question, in fact. Let's just shrink the screen a little bit. There, and we'll do one further example at the bottom. So here's another example. Let's say we want to calculate the percentage by mass of potassium again. Let's just keep it easy. Of potassium in potassium hydroxide. Now, potassium hydroxide has the symbol KOH. K is potassium, O is oxygen, H is hydrogen. But potassium hydroxide as a compound is KOH. And we want to know the percentage by mass of just potassium. So first of all, let's get the AR values of each of the things that we've got. So the AR of potassium we know is 39. For the oxygen off the periodic table we can see that it is 16. And for hydrogen we know that is 1. So that gives us a total of, well, 39 plus 16 plus 1 comes out as 56. So let's just write that in there. So the individual AR values for K, O and H add up to 56. So 56 now, because we've added them all up, is our MR. That's our relative formula mass. And the original question said we want to know the percentage by mass of potassium on its own. So again, just like we had in the previous example, potassium is 39. We want that as a proportion of the 56 that we've got, and then we times that by 100. And if we do that sum, so 39 divided by 56 and then times by 100, that comes out, if we round it up, or let's say we take it to one decimal place in this example, that would come out as 69.6%. And that in a nutshell is how you calculate the percentage by mass of an element in a compound. You look at each individual element and you get the AR value, the relative atomic mass. It's basically the mass number, but we use the word relative to take into consideration any isotopes of that element. Then you work out the relative formula mass, so you just add up all those mass numbers of each of the individual elements, and then you do it almost like a percentage. How much of a proportion of the thing do we have of the whole thing? Okay, hope all that helps.